Oh, good morning, everyone. Hope everyone's doing great. Everyone's doing all right. Last class, we closed out 11.2. So we jump to 11.5, and then probably just do 11.5 today. In next class, we do 11.3 and 11.4, and that'll be it for chapter 11. All right. So 11.5 triangles. We're going to start off with the idea of the angles of the triangle. All of them add up to give you 180 degrees. So from this point forward, they will assume that you know or remember that when you have a triangle, all three of your angles add up to 180 degrees. All right. So first example, leaning on that premise, it says that find the measure of angle A for the triangle ABC. And so you see that in the figure, they give us 120 for angle B, 17 for angle C, and then A is the unknown. All right, so if you just had to put it in equation form, that means, angle A plus angle B plus angle C is going to be equal to 180. Go ahead and substitute the values that you know, then solve for the value that you do not know. So that's 120 for the B, 17 for C. Add them together, you get 137. Then subtract them from both sides, or at least subtract them from the 180. And that will give you 43 degrees for angle A. All right, scrolling up. Okay. Erase some of this stuff down here. All right, so in the diagram, the measure of angle C is 40 degrees. The measure of angle E is 60 degrees. Find the measure of angle D. All right, so let's walk this one out. As a matter of fact, scroll up, right done with that red. Look like I did last time. Get it all in here. All right, so just like before, last section, I had a little explanation as to how we got these values. So let's look at it. They give us angle C and they give us angle E. And I put that right here just to emphasize that relationship or what they gave us. Now, the first angle that we can find, now we're trying to find D, but we're going to have to find A and B in order to get to D. And if you don't see now why, you'll see in a second. The first angle that we know we can find is A because it's a vertical angle with E. So that means if E is 60, A is 60. And that's why I wrote down here, vertical angle with E. And then if I want to find B, we have a triangle right here. So that means angles A, B, and C add together to give you 180. So that's what I wrote right here. I just took 180 and I subtracted A and C from it. And that gives me 80 degrees. So before we go any further, is everybody okay with how we got A and B? Once again, A is a vertical angle with E, so that means it's equal to E. And then to find B, we recognize that we have a triangle right here. And so all of those angles have to add up to give us 180 degrees. So now to finish it off, we want to find D as in dog, and that creates a straight angle or straight line with B. So what I would do is subtract B from 180, and then that will give me D, which is 80 degrees. I mean 100 degrees, excuse me. Do 180 minus 80, which is 100 degrees. Questions on what we did there, make sure we're okay. I'll scroll up soon. I'll go too far, of course, let me know. Good. Everybody good, scrolling up. All right, let's look at our triangles and their characteristics. So you can classify your triangles by the angles. First one is an acute triangle. All angles are acute. We talked about what it means to be an acute angle last class. Acute is an angle that's between 0 and 90 degrees. Right triangle is one angle is 90 degrees. Then for an obtuse triangle, which I'll scroll up in a second, one angle is obtuse. Yeah, that's cute. Yeah. If I get on acute. All right, next we can classify the angles by sides. The first one is isosceles. When two sides have equal length. And so notice a little note there, angles opposite their sides will have the same measure as well. So if you have two sides that have the same length, that means you have two angles that have the same measure. All right, one of twos. All right, so equilateral triangle, all sides are equal. That means all measures are equal, which also means since you know it's 180 degrees for each angle. I mean, when you add up each angle in a triangle, dividing by 3 will give you 60. So all of them are going to be equal to 60 degrees. Last one, scalene triangle. No two sides are equal in length. That means no angles are equal in measure. Let's scroll up. I have to go to the next page, so I'll wait for you to finish. All right, everybody good? So, good, good, good. All right, let's go to the next page. Still the same section. So let's look at similar triangles. So when we say that an object is similar, they have the same shape, but not necessarily the same size. All right, let's scroll up on that first statement. All right, so properties. The ratio corresponding sides are equal. The ratio corresponding heights is equal to the ratio corresponding sides. And the measure of corresponding angles are equal. So probably gonna make more sense when I put some numbers on it. You'll see that in a second. But yeah, those are properties. Those are properties. All right. So if I scroll up and somebody's copying, let me know. All right, so let's look at these two triangles right here. They're similar, but of course they're not the same size. You already see the measurements that we're given. But they say that our sides are supposed to correspond to each other. The ratio of the course of size is supposed to correspond. So if we look at AB and I try to color code, what we're looking at, AB is this base side down here. It corresponds to DE. And so if I set my ratio up as small triangle over the larger triangle, I took the side of the smaller one, which is 2, placed it over the side of the larger one, which is 6. That reduces down to 1/3. Anybody hold on to that black sentence up top? Okay. So BC is over here to the right. EF is what corresponds to that side. And so that's 3/9, which would still be 1/3. And then AC over DF 4/12, which once again reduces down to 1/3. So we see each one of these ratios of corresponding sides are equal to each other. So that's the properties of your similar triangles. Mhm. Mhm. Scrolling up to an example, very good. All right, let's look at triangles A, B, and C and D, E, F. They are considered similar and they tell us to find FG. All right, so we want to find the height of this triangle, which is FG. And how you want to set up your ratios up to you. You can do small over big. I tend to do it that way. Small size over larger side, big side over smaller side. It's just up to you how you want to handle it. But whatever you do, you have to stay consistent. You know, like I said, 3 or 4 different, 3 or 4, it should be 4 different ways that you can set them up. But as long as you stay consistent across your proportion, you'll still get the same answer. So make sure you're consistent with that. So I decided to set it up as small side over larger side. So I took my AB, which is this base of my smaller triangle, and place it over DE, which is the base of my larger triangle. So that'd be 8 over 12. And then CH, which is the height of my smaller triangle, and place it over the height FG of my larger triangle. And FG was the missing side that we were looking for, so I just called that X. So it's 4 over X. Questions on the setup before we go ahead and solve? Of course, that is equal. I just went ahead and put my arrows there. But that's 8/12 equal to 4 over X. Once you have your proportion set up, you go ahead and cross multiply, sending your denominators to the opposite numerators. That'd be 8 times X equal to 12 times 4. Anybody holding on to the triangles? All right, go. Then divide both sides by 8, because we had 8X equal to 48. Finishes off the problem with X equal to 6. All right, everybody okay with that one? Let's see writing, so I'll wait. All right, another couple statements that will help you out when it comes to solving for these angles in your triangles. So if the three angles in one triangle are equal in measure to the three angles of another triangle, then the triangles are similar. So you can tell if your triangles are similar, if their angles are equal, and if they're similar triangles, then we can lean on the idea of them having corresponding sides and the equal ratios. So then it says if two angles of one triangle are equal in measure to two angles of another triangle, then the triangles are equal. That's because we know that all three angles are equal to 180. So if you know two of them are equal, that means the third one is going to be equal as well. So both of those statements just go hand in hand. And saying basically, if you know that two of them are equal, you know that third one is equal. And if all three are equal, then that means you have similar triangles. Okay, how we doing that first statement? And right here is just a diagram emphasizing that second statement. Basically, if you know these two are equal to the two that's over here in this other triangle, and then that third one has to be equal as well. And here, just remind you some of the angles in the triangles 180. How are we looking at that last statement up top? All right, erasing some stuff in a second. Very good. About okay with that orange statement up top? All right, let me erase some of this stuff. That's not gonna be. Hmm. All right, so we have a figure right here. It says B and D are right angles. AB, that side AB is 12 meters. Side DC is 4 meters. And AC is equal to 18 meters. Find the length of CO. I'll give you a chance to write that down before we get into how to solve it. All right, so let's look and see how we can solve this question. So first of all, we want to see, do we have similar triangles? We know that angles B and D are equal because they're right angles. So we know we have one angle that's equal. And then we know here, these two angles are equal because we have these crossing or intersecting lines which create vertical angles. So if we know two of them are equal, that means all three of them are equal, which means we have similar triangles. So that leads on the statement that we just finished talking about. And since we have similar triangles, that means we have corresponding sides that will create equal ratios. So we want to find CO, which is this right here. But they give us this whole line, which is AC. So if that's the case, what we can do is break that up into two pieces. They give us this total right here, which is 18. I can break that up and call one piece X and the other one 18 minus X. So whenever they give you a total and you want to break it up into two pieces, you can call one of the pieces X and then the other one that total number minus X. And then you will be able to solve moving forward. So that's what we did here. Once again, I broke 18 meters up into X and 18 minus X. So now I can set up my proportion. I'm going to take the small side of my triangle, place it over the big side of my triangle. So DC and AB are corresponding sides. Those are the sides that have the right angle and that I guess you would say double slash for the angle measurement. And then CO corresponds to AO. So it means I'll do 4 over 12 equal to X over 18 minus X. Once you have your proportion set up, then you will cross multiply. And that'll be 4 times 18 minus X equal to 12 times X. All right, so from there, solve. Distribute 4 times 18 is 72 minus 4X equal to 12X. All right. Add 4X to both sides, they'll give you 72 equal to 16X, then divide by 16, X is equal to 4.5. All right. Very good. Almost finished. Congruent triangles, I believe, is the last thing we're going to hit today. So everybody doing their last example? So congruent triangles, they have the same size and same shape. So we have 3 theorems that will help us determine if we have congruent triangles. So depending on the scenario, use one of the 3 that will help you to determine that. So the first one is side, side, side. So if the sides of one triangle are equal to the sides, the corresponding sides of another, then the 2 are considered congruent. Oh, ain't got a take your time. That was good. My bad. All right, how we looking on the red statement? Very good. Good. All right. So side angle side is the next one. So the two sides and the included angle of one triangle are equal to that of a second triangle, and the two angles are congruent. So little diagram to show you what they mean by that. Two sides and the included angle is side angle side. So if those are equal, then the triangles are congruent. We got one more statement. Good on the purple. All right. Third theorem, angle, side, angle. So two angles and the included side of one triangle are equal to that of another. Then the two triangles are congruent. All right. So we want to determine if we have two congruent triangles. We have A, B, C, and for A, we have angle 45, B is 80 degrees, C is 55 degrees. And then for D, E, F, D is 55 degrees, E is 80 degrees, and F is 45 degrees. All right, so these triangles are not necessarily congruent. They do not satisfy either one of the theorems that we have. Remember, the theorems that we had was side, 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 angle, side, angle. This is basically angle, angle, angle. So all three angles are equal, and that's not one of our theorems. So it may be congruent, but you don't have enough information to determine if these triangles are congruent or not. So once again, you have three angles that are equal. Our theorems, we have one is side, 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 one is side, and one is angle, side, angle. But neither one of them are angle, angle, angle. So this is not enough information to determine if they are congruent. So we got one more, just so we have an example of one that does fit one of the theorems. All right, going up. And so these triangles are congruent because they satisfy side, angle, side. So we see that we have 16 centimeters, 60 degrees, 18 centimeters. And then over here we have 16 centimeters, 60 degrees, 18 centimeters. So the sides and their including angles are equal. So that makes the triangles congruent. Mhm. Oh, forgot about one more thing, the Pythagorean theorem. I know that's the last thing, Pythagorean theorem. So your Pythagorean theorem, that's a squared plus b squared equal to c squared. It only applies to right triangles though. So if your triangle does not have a right angle in it, then you cannot use the Pythagorean theorem. So A and B are interchangeable. They can be either one of the other sides that's not opposite the not opposite the 90-degree angle. That 90-degree angle sets up what is what we call the hypotenuse. That's your longest angle. I mean, longest side. Excuse me, I get this right. The longest side is your hypotenuse is opposite the 90-degree angle, and that's always on one side of your equation by itself. Like I said, A and B. Doesn't matter which one you call A or which one you call B, as long as it's not the hypotenuse. Scroll up on that last one. All right. And so these are just some of those same statements that I mentioned. Like it's only used for right triangles. C is always the hypotenuse. C is always the longest side and opposite 90 degrees. Then, like I said, I scroll up in a second. Uh, and the last two statements, once again, I've already said that just that's it written out. C is always on one side of the equation by itself, and then A and B are interchangeable. All right, so an example that uses the Pythagorean theorems asks us to find the missing side, and we have 5 centimeters for one side, 12 centimeters for the other side, and then we're missing The actual longest side, which is going to be C force, is the one that's opposite that 90-degree angle. So we know A squared plus B squared equals C squared is our formula. Once again, A and B are interchangeable. The one that has to be established, the one that is different than the other two sides is C. That's your not Pythagorean theorem. I can't get my words out this morning. C is your hypotenuse, which is opposite at 90-degree angles. So we have C on one side of our equation, A and B on the other side. So 5 squared plus 12 squared equal to C squared. 5 squared is 25. 12 squared is 144. Add together is 169. Now remember, we're solving for C, not C squared. So we need to get the squares off of the C. And the way we do that is take the square root of both sides. Once you take the square root of both sides, that will cancel out the square. This one's C. And then the square root of 169 is 13. And that'll be your answer. Always remember, if you set this up properly, C is supposed to be your longest side. So you see that 13 is, larger than 12 and the 5, of course. But if that doesn't work out that way, then somewhere you did something wrong. A and B are supposed to be shorter than the length of C. All right. Questions, concerns, comments, anything, anybody? Ready to go. So that's all we're doing today. Like I said, next class we'll do 11.3 and 11.4. They pretty much do those two together because of the nature of the content. Other than that, you guys have a good day, be safe, and I will see you on next class.